Right, so today we're going to learn about acids and bases. So some examples of acids are hydrochloric acid, which chemical formula is HCl, sulfuric acid, which is H2O3, and nitrous acid, which is HNO3. Now, to determine whether a substance is an acid, it will have an H at the beginning of it. Some properties of acids are that acids taste sour. Also, they are corrosive and will dissolve metal. And when they neutralize bases, they produce salt and water. Some examples of acids in real life are car batteries. We use acids in swimming pools, and we use them for preserving food by pickling them. Okay, so now we're going to learn about bases. Now some examples of bases are sodium hydroxide, potassium hydroxide, and lithium hydroxide. And their chemical formulas are, for sodium hydroxide, NaOH, potassium hydroxide, KOH, and lithium hydroxide, which is LiOH. Now, the way to tell apart a base from an acid is that all bases end with OH. Some properties about bases. When you taste bases, they are bitter. Also, when they neutralize acids and produce water and salt. And when bases react with fat, they create soap. Some examples where we use bases in the real world: we use them in car batteries, we use them in cleaning products, and
welcome to acids and bases. Acids and bases are measured on the pH scale, which is a range of 1 to 14. And acids are from 1 to 6, and bases are from 8 to 14. And in the middle we have neutral. So some examples of acids are lemon juice at 2, apples at 3, and milk, surprisingly, at 6. And an example of a base, or a neutral would be pure water. And some examples of bases could be bleach, drain cleaner, and baking soda.
Good morning, class. Today we'll be talking about what happens when you mix an acid with a base. So you have an acid and you have a base, and when you mix them, the base neutralizes the acid. So the neutral substance that you're left with is water. And you're also left with an ionic compound that will change depending on which two substances you're mixing. So an example of this would be mixing hydrochloric acid, your acid, with strontium hydroxide, your base. So like I said before, you're always left with water. So you have water, and then the other product that you have is made from what's left over: the chloride and the strontium. So you're left with then strontium chloride. Pretty straightforward. So now let's do a balanced chemical equation. So you have hydrochloric acid, which is HCl, and strontium hydroxide, which is SROH, which reduces water and strontium chloride. Now we have to balance this. Strontium has a charge of 2, whereas hydroxide only has a charge of 1. So when you do the crisscross, you're left with a 2 down here. The same thing over here. Strontium is 2, and chlorine only has a charge of 1. So you're left with a 2 down here. Now Now you need to make sure that you have the same number of everything on both sides. So, you have 1 hydrogen plus 2 makes 3. And over here, you have 2. So we need to make that equal. So the easiest thing to do is add a 2 here. So now we have 4 over here because it's 2 times 2. So then you add a 2 to the beginning, and you have 2 plus 2 is 4. So now you have equal hydrogen. Chlorine, you have 1 here, but now made 2 because of the 2 there. And you have 2 here, so that's equal as well. Strontium, 1, 1, and then oxygen. You have 2 here, and you have 2 here. So there's your balanced chemical equation.